Okay, I'm requesting all of you, please close your hands for the prayer. Om Shahana Bhavatu Shahano Punaktu Shahuvirjam Karvavahai Tejashina Tamastu Ma Vidvishavahai. Om Shanti Shanti Shanti. Anita, now you can start.
So please make me host so I can share my screen.
Yeah, you can share the screen.
Okay, thank you. So we're just going to look at a little bit of what we've already discussed. If we remember our discussion in our last class, can anyone tell me what are the two indices that we discussed in item analysis? Anyone? What are the two indices? Yes, sir. Dharni sir was there in the class last time. So if it's possible, please do type in the chat, Dharni. I would really appreciate it. But Prasanna sir, follow along with us. You can listen to the class later on as well. So that shouldn't be a problem.
Sure.
So the two indices that we typically talked about in item analysis is item difficulty and item discrimination. For our test to be even used in the right way, for our test to be valuable in any way, we need to have a tool that is discriminating in nature. For example, what we mean by the word discriminating is that it should differentiate between those who are scoring high and those who are scoring low. So when we say that a tool must be discriminating for our usage, it is the entire factor that a tool, if it is discriminating, will give us an idea on whether somebody in the population has a particular trait or that particular behavior, and whether somebody does not. So it should be able to differentiate between those who have the trait and those who do not. So we talked about item discrimination and we talked about item difficulty as well. Item difficulty talks about the proportion to which the number of people that can get your answers right for each item. So we also discussed that for ability and intelligence testing, we always have one right answer for each item, and therefore that will automatically become the right keyed response. But when we say that there is a right answer for personality test or personality inventories or anything that is related to temperament, we do not exactly have one right answer. But in that case also, we need to have an understanding towards what makes a tool item difficult. So therefore we choose the rating, or we choose the answer of the item that indicates the presence of a particular trait as the right answer. So we're just going to go over these topics once more so that we can get an idea, and then we're going to learn how to calculate this in our Excel. So if you had had a look into the Google Classroom, I had already sent you a tool and asked you to collect some data, at least data of 6 people, upon which we will gather our item difficulty and item discrimination values. So we're just going to follow along with those data. I have a data set of my own, which I will be demonstrating to you. So if it is possible for you, you can follow along with me on the side, or you can take your time to listen to this video and then do it on the side later and share it with us through Google Classroom as well. So that's up to you. So just a quick recap. We're just going to do a very quick recap about item difficulty. It is the proportion of the complete sample who put in the keyed response. Keyed response here talks about what the right answer is. So for ability and intelligence testing, we have the absolute right answer. But for temperament and personality inventories, we have the answer that indicates the presence of a particular behavior or a trait as the key response. So we also talked about how the endorsement rates should be between 80% and 20%. So if an answer is not getting more than 20% of your respondents to get them to respond to this particular item, it means that the item is too difficult. So therefore, we will have to discard that item. Or if an item is getting more than 80% of your respondents in the right answer, then it means that it is too easy that almost everybody can answer. And it's pointless to include that item in a discriminative tool. So therefore, you can reject that item as well. So anything that varies between 20% to 80% difficulty is acceptable, but at the same time, we'll have to work with modifying these items so that they can fall within the right category of difficulty. Moving on to the next topic, just a quick recap, item discrimination.
Before you go further,
yeah.
Basically, the previous slide is about a normal distribution curve, right?
Yes.
So, what is the 2080 comes into the picture here when actually you have only 3 segments of the normal distribution? Is there anything correlating?
Yeah. So, what we're talking about here is essentially that here the 68% is roughly how much we will have items covering, right? So, this is where we'll have our most of the item difficulty coming into. So, we will have to have the endorsement rates within 70% of the entire population's responses. If more than 30% are not able to respond, then we'll have to revamp our items so that it will have to get somewhere in between. Or if less than 30% of our respondents are able to get the right answer for this particular item, we'll have to again rework the item again. So what we have as the red area is where our difficulty range should be for our difficulty value. Does that make sense to you, sir?
So I hear that. So, okay, go ahead. No issues.
Yeah. So it's just a graphical representation for us to understand. The extremes are anyway going to be discarded, but the blue areas are still going to be scrutinized so that it falls under the red area. That's the entire point of that graph. So moving on to the next one, item discrimination. We talked about how a tool needs to be discriminating between those who score high and those who score low. This is essentially for us to get an understanding of how the distribution of the entire trait is in our sample or our population. And this is the entire point of our tool. Right? So that's the reason why we talk about item discrimination. So based on item discrimination, there are 2 ways in which we talked about item discrimination as well, item reliability and item validity. Item reliability is the consistency with which we can predict which category of member will fall under with their particular score. For example, if we have a low score and we say the item is reliable, we expect a low score from this person again in the future if we administer this test again to them. So the consistency is something that we are trying to understand in item reliability. And in item validity, we're trying to understand how much this particular item is able to differentiate between those who score high and those who score low based on some criterion that is already available. So how valid is this particular item in measuring the trait that we want to measure is what we talk about in item validity. Does it actually measure this particular trait that we want to measure based on who's scoring high and who's scoring low? That's the question that we answer in item validity. I hope that makes sense so far.
Yes.
Awesome. So we already covered a little bit of this in detail in the previous class. So if you can just listen to that YouTube again, that will make a little bit more, clarify a lot more things with regard to these topics. But we're just going to quickly go on to what we're going to do today. So we discussed about the ICC. It's not going to be discussed in today's class. What we're going to do today is item analysis. Basically, we're going to calculate the item difficulty and item discrimination. So we're going to start off with calculating item difficulty, right? So there are 4 steps that we need to go over when we say we're going to go ahead with item difficulty calculation. The first step is we arrange the scores according to the total in a decreasing order. For example, we calculate all the total scores. So since we gave you the G87 tool, you're going to have 7 responses for one individual. So you'll have to calculate the total for all of these 7 items, and you will get a total score for each individual. So based on that total score, we will arrange these individuals from the highest to the lowest score. So that's the first step that we need to do. So the second step that we'll do is find the top and the bottom 27%. Now there comes a question, why this 27%? That's a very good question. That's also a question that I got when I was reading through this particular topic while attending this course before. So here's the answer. So there's a theory called Kelly's dichotomization. So in this dichotomization, we're trying to figure out what is the higher scorers population and who are the lower scorers population in this entire distribution that we have, that we collected data from. And selecting 27% of high scorers and 27% of low scorers is the best way to establish the difficulty value of an item. It is the most, what can we say, reliable percentage that we can calculate when we say the difficulty of an item. That's why we're considering 27%, that is on the higher end, and 27% on the lower end. If we consider any lesser than that, then your items can go here and there. We do not have an absolute understanding towards who is scoring high and who is scoring low. We are leaving out a large population in between if we are choosing something much lesser than 27%. For example, if we are choosing 25 or even lesser than that, we will not get that clarity towards the population that we're leaving out in the middle. But if we say 27 typically, 27 will usually cover a large number of those who are scoring high and a large number of those who are scoring low. And this is what we need to understand when we say item difficulty, because the people who are there in the middle are there in the middle anyways. So those who are scoring high and low will be the ones who are determining how difficult an item is, right? So therefore, that is our second step. We'll calculate the 27%, how many people come under the 27% on the top and how many people come under the 27 on the bottom. That's something we'll do as a second step. Moving on to the third step, we will look at the calculation of the difficulty value using the formulas. Formula is something that we'll look into next. And then once we have the values, we will try to interpret these values using the theory that we have, Abel's theory of interpretation of DV and DI. That's something we'll look at as well in the upcoming slides. I hope this makes sense. Any doubts in this?
So when you say top 27 and bottom 27, so
yes,
wouldn't be ending up 54% of total sample? Or
yes,
that?
Yes.
And that is the reason why we're going for 27, because anything
Exactly.
beyond 50%, we have that major stake.
Exactly.
Okay, then why not so 26%?
We can consider 26, but calculating 27 has been proven to be effective enough in research studies. That's the reason why we took this into our consideration.
Okay.
Yeah. So based on empirical evidences, this is the number that makes more effective sense when we say item difficulty, and that's the reason why we take 27% as such. So with that, we're moving over to our formula. So the formula for calculating item difficulty or difficulty value, as mentioned here, DV is equal to the number of right answers in the higher group plus the number of right answers in the lower group divided by number of people in the higher group plus number of people in the lower group. I'm repeating that again just to make sense to you again. So the number of right answers in the higher group plus the number of right answers in the lower group entirely divided by number of people in the higher group and number of people in the lower group. So since here we're taking only 27% on the higher and 27% on the lower, we're going to have an equal number for both NH and NL. So it's going to be twice a particular number, that's all. And right answers in higher group talk about how many people have keyed in their responses that you deem as the right answers in the top 27. And right answers in the lower group talk about how many people have gotten the keyed response in the lower 27%. Right? So if you can just make a note of this very quickly, we can revisit this when we're doing our calculation. Right? So it is DV is equal to number of people in the number of right answers in the higher group plus the number of right answers in the lower group divided by number of people in the higher group plus number of people in the lower group. Make sense? Can I move on?
Yeah, please.
Awesome. Great. Thank you so much. So moving on to calculating item discrimination. Again, we're going to follow the same procedure as we did for the calculating of item difficulty. We're going to arrange the scores in decreasing order. We're going to again find out the top 27 and bottom 27 percentage. And then we're going to apply a formula to calculate the BI and then interpretation. It's the same 4 steps again, but the only thing that changes is our formula. So moving on to the formula here. Formula is the only difference you can see here between the other formula is that there's a minus on the numerator. So number of right answers in the highest group minus the number of right answers in the lower group divided by number of people in the higher group or number of people in the lower group. So we're only going to consider this or that. There's not going to be a plus in the middle, right? So we're trying to differentiate between those who are in the higher and the lower group, right? So therefore the symbol changes to minus, and we are going to consider either one or the other number for our denominator. Does that make sense?
Yes.
Awesome. So with this, we are going to go ahead with calculation because the next slide that we have is towards understanding this Abel's criterion of interpretation, which we'll get to when we get the values, right? So we'll talk about it along with the values. So I'm just going to stop my screen right now, and I'm going to go ahead with opening in my Excel and sharing that screen with you all. Just give me a moment. Yeah, okay. I hope my screen is visible for you all.
Yeah.
Awesome. So I've just calculated I've obtained data from around 15 people. So this is the data that I obtained. I've calculated the total values for each individual here in the final column over here. And I've arranged them in the descending order. So as you can see, 6 is at the top and 2 is at the bottom of this entire list. So based on the total score, I've done the first step and the second step. We're going to do it right now, right? So first step is that we have calculated the total score and we've arranged it in the descending order. So this is what we have right now as the entire data set. So based on this, what was the second step that we had to do? We had to calculate the top 27% and the bottom 27%. So obviously, we're just going to simply apply a formula here that we have already done. I'm just going to type it out to you. So is equal to 15 into 27%, therefore 0.27 is what we will type here, which will give us a value of 4.05. So 4.05 roughly talks about 4 people. When we round it up to the closest integer, it becomes 4. So we're going to highlight the top 4. I've done that already. So we've highlighted the top 4 people's scores and the bottom 4 people's scores based on the entire decreasing values that we've determined, right? So this is what we'll do as the step 2. So once we're done with step 2, we now have to go ahead with step 3, which is applying the formula. So in step 3, while applying the formula, I'm going to type it along with you so that you can go ahead and do it along with me for your data set. So we'll do sum. So equal to sum. So here the sum is about I've calculated the number of right answers here and number of right answers in the lower group as well. Please keep in mind the number of right answers does not have anything to do with your rating value. So since we have 2 and 3 as our rating values here, this is something that we need to consider along the rating scale. So since we have the entire rating scale here, we're going to have values that indicate 2 and 3 all along the scale. So we're going to have 0, 1, 2, and 3 for this particular tool. So what we're going to consider here is when we talk about this tool's interpretation, we get an understanding that if a person scores lower than 5, they are not having a diagnosis of any kind of anxiety disorder. But if a person scores from 5 to any point beyond that, to the entire total score that's possibly obtainable, it means that they have some grade of general anxiety disorder. So this is something that we need to take into account. So therefore, any score from scoring 5 to the entire pointer of whatever the total score can be possible for the tool, which is 21 is the total score that's possible for this particular tool. So along this particular range of 5 to 21, any score between this does indicate the presence of the generalized anxiety disorder according to the interpretation. So what we're going to do here is we're going to take the zeros as indicators of the wrong answer, because it does not indicate the presence of anxiety at all. And any value between 1 and 3, we're going to consider it as our right answer because it indicates something towards anxiety. Do I make sense to you?
Got lost. So 2 points. So the item 7, the 7 items are there.
Yes.
So right answers are the wrong answers. It's purely determined by 0, 1, 2, right?
Here we have a rating scale, sir. In this particular scale, we have a rating scale that is scored from 0, 1, 2, and 3. So we have 4 points in that rating scale, 0, 1, 2, and 3. So in my data set, I do not have anybody scoring 3, but I do have people scoring 2 in this entire data set. So what we're trying to do here is we're going to look into the interpretation of this tool. With the interpretation of this tool, it indicates that a total score of 5 to a total score of 21 indicates the presence of anxiety disorder, generalized anxiety disorder. It is a diagnostic tool. So therefore, we need to take into consideration anything that indicates anxiety's presence in this particular individual needs to be keyed in as the right answer because it indicates the presence of the trait that we're trying to measure. But when a person indicates themselves on the rating scale of 0 to 3 as 0, it indicates that they do not have that particular symptom according to the scale. So therefore, that is what we're going to take here. So those who keyed themselves as 0 on the rating scale, we're going to take them as the wrong answer. And any rating from 1, 2, and 3, if a person is indicating, we will take that as 1 to the right answer.
Okay. This scale, the GAD scale, if the parameter, whatever. So the client is expected to give any numbers between 0 to 5, right?
No, it's only 0, 1, 2, and 3.
1, 2, 3. Okay.
Yes.
Okay. So 3 is the maximum number that they can give.
Yes.
So,
yes.
And for DI, we are going to take every item level, or DV, we are going to take every item level.
For any of these things, we are only going to consider the number of right answers and the number of wrong answers. So here, when we say the number of right answers, we're taking those who are rating themselves from 1, 2, and 3 as people who are keying the right answers. That's all.
Okay. Okay. Because I got a little confused with the total. What is the role total really playing? When you want
total here is for us to just arrange them in the decreasing order. The total will not have anything to do with our calculation.
Okay. So what do you, okay. That's the reason A is lying in row number 10. Okay, now I got it.
Yeah, okay. Exactly. So based on the total, I've arranged the entire data set into a decreasing order, and that's why we have this entire jumbled letters towards the side, because I've just labeled them according to the data I collected. And since I arranged it again, that's the reason why they're all jumbled. So since we have this entire decreasing value, that's the only role we'll play with the total score at all. Apart from this, the total score will not be involved in any part of the calculation. So we're only going to consider this entire item scores that we have for all of these tools, all of these entire 7 items across all our samples. So for which, that's what I described as 0 being the wrong answer, and any indication from 1, 2, and 3 being the indications towards right answer. So with that idea, let's take RH for our first item here. So people who are in the entire higher range here, we have to calculate the number of people who have answered the right answer. So here, since we already discussed that the right answer is indicating towards the presence of anxiety, 3 people have scored 1. So therefore, there are 3 right answers amongst the top 4. Does that make sense, sir?
Yeah, I'm getting the point. Okay.
That's okay, sir. We'll just follow along with it again and I will clarify further doubts for you. I think you will also get a hand when you're trying this out yourself.
Again, mind is going something else, like similar methodology of statistics somewhere else is getting applied. So trying to correlate that. That's what I'm getting confused. No issues. Go ahead.
Of course. I understand. That's all right, sir. If it's possible for you, we can also discuss that toward the end of our class. Let's hope we can complete this before half an hour so that we can have that discussion as well. So the number of right answers in the lower group, since here we can see there are only 1 in the indicators. There is 1 given by K and 1 given by D here. Therefore, the answer here is 2. So RH for item 1 is 3 and RL for item 1 is 2. So we're now going to apply the formula of DV and we're going to calculate, right? So we have the NH and NL value, which is the total number of people in the higher group and total number of people in the lower group, which is 4 plus 4 and 8. So we're just going to keep this denominator as 8 for DV. So what we're going to do is we're just going to write equal to sum, open the brackets. We're going to type RH is indicated by the cell B17. So we're going to write B17, comma, B18. As we can see here, B18 is RL. So we're going to add these two, which is clearly indicated by the sum, divided by 8 is what we already discussed. So we will get the value 0.625. This is the value that we get here. That's what I pasted over here. So as you can see in our formula bar over here up top, I've done the same calculation here in this particular box of DV for item 1 as well. I hope that makes sense. So I'm just going to copy and paste this over here. Yeah, so we've calculated the difficulty value for item 1. I hope you're all following along with me on this. So this is what we're going to do here as well. So here, can one of you just tell me what formula we're going to use so that we can just get an understanding toward that as well, whether you're following me or not.
You want a value or a formula?
Both. I would like both.
So DV should be 4 by 4 plus 2.
Yes.
6 by
yes.
8.
Yes. So we have C17, C18 as our cells which have the value divided by 8.
0.75, right?
Yeah, 0.75. Exactly. So I'm just going to do this very easily for all of us to follow along. I'm just going to extrapolate our first formula into it. So we now have the values of DV for this particular data set. So this is something you can just look at. We will also compare it side by side when we're talking about the interpretation. I will talk about it later. So now we're going to just move on into calculating the discrimination index. So DV is our difficulty value. DI is our discrimination index. So just a recap of the formula, DI is RH minus RL divided by NH or NL. So here we're obviously going to subtract these two, right? So we're going to subtract these two values and divide it by 4. That's what we're going to do. So if you look into the formula that I've done here up top, it is sum B17 minus B18 divided by 4. That's what we've done here. So that's the value that we've gotten here, right? So similarly for this item number 2, if we were to do the same thing, we're going to again write equal to sum, open the brackets, B17 minus B18, close the brackets, divided by 4 and press enter. So we have again 0.25. So I'm just going to again extrapolate this entire thing to our whole item number 7.
It was
So
0.5. There was a mistake, I think.
Come again?
It was 2 by 4, so it should be 0.5. Now your dragging came in properly, but earlier calculation shows 0.25.
I did not get
Column
that right.
C, column C,
which value?
It's 0.5. The calculation that you explained showed that it's 0.25. That's what I was trying to say.
Okay. Now it's right, sir.
Yeah, it's 2 by 4. That's what 0.5.
Yeah, it's correct. Yeah. So this is the value that we've gotten so far. So we have values for each of these items across the 7 items. So we have DV and DI for each of these values. So just to go along with this, I'm just going to include another thing. So I'll just stop sharing this screen for a moment and I will get back. I will just put the tables side by side so that we can follow along with it. Okay, I'm going to share the screen with you all. The entire screen. Yeah, so is my screen visible now?
Yeah.
Awesome. So we're going to first talk about the difficulty value, the DV, and the interpretation of DV. So as we can see here, you can clearly understand that each of these values will be pertaining to each interpretation that's mentioned here. So can we have an idea about what item 1's DV interpretation is?
No, except.
So it lies. Yes, sir. Please go ahead.
No, column F and H, all of them are on easy or made easy, right? Most easy, right?
Sorry. Yeah. So here, if we look at this 6.25, this 7.5, 7.5 again, 6.25 again. So all of these three, our item number 6, our item number 4, our item number 2 and 1 are all coming towards the easy category. And one of it is even most easy. Item number 2 is most easy. So that is our interpretation. What's happening with item number 3?
Moderate difficult.
Yeah, it's moderately difficult. But item number 5 over here is 0.25. So it comes under most difficult. So can we get an idea towards which are the items that we can consider and which are the items that need to be rejected based on the difficulty value?
Yeah, of course, item 2 and 4 are rejected, can be rejected because it's most easy, right?
Yeah, absolutely. 2 and 4 can be rejected. Absolutely. We can consider items 1 and 6 to an extent, but we need to do a little bit of modification so that they can become a little bit difficult, so that we get them into the moderate difficult level as well. But what happens to item number 5? Do we accept it or do we reject it?
When this is a moderate difficult, why you want to disturb that? Here it's moderate difficult, right?
Item number 5, sir. Item number 5 is 0.25.
Oh, 0.5. Okay.
Yeah. So should we accept that?
Yeah, you should accept, right?
But only 25% of my entire sample have been able to answer that question. So will it make sense to me to just accept it as this?
Oh, okay, I'm lost.
So we've already cut off that limit, right? We have cut off that limit of less than 20% and more than 80% difficulty are not to be accepted at all. That's the entire point of having interpretations in between these two cutoffs. But here also, if we have an interpretation that says most difficult, it's still subject to a little bit of improvement. We can still make a little bit of improvement to make it difficult or moderate difficult. We should not have it as something that is most difficult, because if only 25%, that is less than, that's approximately a quarter of my entire population, that's even able to get the answer right. So what happens to 3/4 of my population? Does that mean that they are not able to understand the item? Or is it going to be too difficult for them to answer this particular item? I'm leaving out on so many things for my entire 3/4 of the population. So if I'm able to get it a little bit towards maybe 40% of my population being able to answer, or even 35 to 40. That will be a little okay.
No, it's confusing. So the intention of the GAD or this thing here is to know whether GAD is there or not. So 0 makes there's no anxiety at all, right? And the reason why you got 0.25 here is majority of the crowd gone beyond 0. Then how can we say it's a difficult?
So people may not exactly understand what your item is actually asking, and therefore they might rate themselves as 0 because they don't want to come across as, randomly rating themselves as anxious. So in this case, we need to look into the item's characteristic. Is there anything else that can talk about what is increasing the difficulty of this particular item? Because if more than 1/4 of my population is not able to answer this item with regard to the trait, then it kind of means that there's something that we need to look into as a part of your item itself, right? Because if people are not able to understand the language or what exactly it's asking, if it is an ambiguous item, for instance, we will usually get that most difficult as the interpretation. So maybe in the sample that I collected, they're not able to understand this particular item to the clarity that is expected of them.
Okay.
So it depends on the sample. Item analysis is very, very dependent on your sample's characteristic. So it is not something where you just talk with very little population. So since it's a very limited population here in my sample size, it's just 15. We're getting all of these data like this. But if we are going to consider a large sample size, then we will get accurate data on this. Maybe we will not get 0.25 for item number 5. But for this particular sample, this is what we got. So what we need to look at is for my sample, for the population that I am choosing, maybe this is not the right way to explain that particular item. Maybe I need to reword it a little better so that more people can answer it.
Okay, Anindita, see, algorithmically, we have sorted this out. Okay,
yes.
As an algorithm approach.
Interpretation of the entire tool according to GAD, that's a whole other ballgame, sir.
I hear that. So, see, you gave GAD as a base for this, right? The people are filling that and you're getting the output of that.
Yes.
So, now what I did here is I use an algorithm that will resort my data. Because of the resorting, certain items, when I say items, maybe that's why I'm getting confused. When you say item, is it a sample 1, 2, 3 like that? I need to read it or something else?
The item is just the question. Each question is called an item.
7 questions.
Yes. GAD 7 has 7 items, which is 7 questions.
And the ABCD is the sample.
Sample, exactly. Each of my subject is labeled with an alphabet.
Okay. So 7 questions is being sorted based on the sample size. Let's say 15, 20, whatever you name it.
Yes.
Okay. And that leads to certain questions as the easier questions and certain questions as the difficult questions.
Yes.
Okay, maybe I need to understand this algorithm better because I'm a little lost. The same, if we apply this sorting, resorting order, right, on this plain data, automatically certain items always will be in the upper limit, right, and something will be in the lower limit.
There's nothing wrong with it being in the upper limit and the lower limit. That's why we have this entire interpretation that's going on, right? So that's the reason why we have the most difficult and the most easy to be revamped a little bit so that it can become better. We're not discarding these 2 levels of these items at all. We're still going to work on it to make it a little better so that our samples are able to answer it better. But what we're looking at entirely as the algorithm is a formula that will essentially give us an idea on how much of my entire sample size is able to answer this question or not. That's the reason why we keep saying the keyed response for the particular item, the right answer that we're considering. So if you are just going to leave out the fact that it's a GAD tool and maybe replace it with an intelligence test, we're going to get an idea of people being indicative of intelligence and people not having the indication of intelligence, right? So 0 and 1 will be indications of that. So if that is the case, we're again going to deal with the same thing. So what the nature of the entire thing is not even going to be a part of our calculation here. Only thing that matters here is about the sample. And of course, your details are going to be limited because it's a very small sample, and that's okay. For now, just for the calculation purposes, this is fine. But if we are actually going to go ahead with the construction of a tool, we will have to extrapolate it to a larger sample size so that we can get a clearer idea.
Can you little scroll on the canvas screen? What is that? The top your title? What title you gave?
Abel's criterion.
Abel's criterion. Okay.
Yeah.
So this is the algorithm name, right?
This is essentially the interpretation alone.
Interpretation. Okay.
Yeah.
Okay. Thanks.
So we can stick to this with regard to our basic understanding of item analysis. Of course, there's a lot more when we talk about where to choose an item, how to choose an item, what else you need to do. There's a lot more statistical interventions and statistical techniques that are involved into constructing a whole tool. But basics of constructing a tool, a very simple tool, we can take this into consideration. Item analysis is one of the most basic things, because apart from this, we will still subject our tool to further statistical scrutiny for a betterment of our tool. But this is the basic thing that we need to understand so that we have a decent set of items before we get to our further statistical analysis.
So is it right to say that this Abel's criterion follows a median-based approach than a mean-based approach?
Yeah.
Oh, that's what I think confusing. Okay. Okay, got it. Go ahead.
Awesome. So moving on to DI here, we're going to talk about the discrimination index. Discrimination index, please be careful when you're looking at the entire table values. But can we have an interpretation towards all of these 7 items? Which one is a very good item? Which one is a very poor item? What are we seeing here?
Column D and it's item 3 and item 5.
Yeah.
To be revised because it's 0.
Absolutely. Absolutely.
Is it a 0 or it is negligible?
The value is 0 here because we have both of it coming as the same value. Both people in the higher group as well as the lower group have answered the same right answers. So therefore the difference becomes 0.
Okay.
So for this sample, this is not a good item. So this is the reason why we keep saying item analysis is a very sample dependent statistical analysis. You need to have a proper representative sample. You need to have a larger sample, and all of those things come into play. But just for the sake of our calculation, for your understanding, items 3 and item 5 have 0. So therefore, we will ideally discard these 2 items. So what's happening with item number 4?
The topper of the class. Very good.
Exactly. It seems to be the excellent item because we have a very clear difference between 5 right answers in group that is higher and only 1 right answer in the group that is lower. So it is very discriminative in nature. This will never happen when you talk about the actuality of a tool. But just in this sample, we are seeing this happening because this is not a representative sample, nor is it a sample size that is enough. So we're seeing this distortion in the scores because of this, just for your understanding. What's happening with item number 1 and item number 6? Are they good to go?
Needs improvement.
Yeah, we need to work on it a little bit so that we can still discriminate our scorers further, because we have only 1 pointer difference between the high scores and the low scores. But when we look at item number 6 and item number 2, we have a very good distinction. So therefore, this is something that we can consider as really good tools, really good items to be included in our final list of items. Are we all on the same page on this so far?
So when you do item analysis, lesser the merrier, right? So because it's in hundreds, really it's going to make the situation a little worse, right? Because it's a median based.
When we talk about the sample size, we need a significant amount of sample at least. Because if I'm going to administer this to adults, 15 adults are not going to give me a representative sample whatsoever. So I need to get somewhat at least 100 and 150 so that I can get a decent idea. of what my characteristic of the sample and the population are, so that I can actually extrapolate it to the entire population. So if we are talking about specific populations that are special, for example, special children, parents of special children, very specific narrow samples that we're talking about, then lesser sample size is good. So that's something we can consider, because the frequency is one thing, but frequency is also completely dependent on number of people that you're also including as a representation of the entire population.
Well, that's a point, right? So, see, according to the parametric models or test, 30 is an acceptable item. So you can very well leverage anything. 30,
The number of
34.
items, however, depends on your variable and what you're looking out for, sir, because that's completely up to you. We have 7 item tools, we have 120 item tools. So it depends on what you are looking at.
When talking about sample size, so 30 is accepted. So my point is, since it's a median driven one, wouldn't, if let's say that I have 150 line items on 5-7 items. So if you go by the 27% of this and everything, wouldn't that the median values or whatever you are deriving, the top 27%, bottom 24%, so it's kind of a skewed, right? Wouldn't be, it's more skewed.
Our assumption is that the larger our sample size is going to be, the more normal our distribution is going to be. Here, if you can see, sir, there's a lot of scores that fall between 4 and 3. So this is our assumption, as usual. We are seeing that, regardless of whether something comes to a median-based analysis or a mean-based analysis, when we assume normality, both of those points coincide. So that's what we're seeing here as well. So since the sample here is very, very small, we're seeing the skewness happening. But if we are actually taking enough sample size to assume normality, and if we do a normality check before we go into our item analysis and our normality test is proven right, then we will have really good statistics to work with. It's not going to be skewed in any way.
Okay.
There's a lot more that goes into it. So this is just the basics of what is needed for a tool. We just need difficult items based on what you're measuring. And we need discriminative items because anything should measure the presence or the absence of the variable that you want to measure.
Okay.
There's a lot more that goes into psychometry than these things. So I think RPRIT does have an advanced psychometry course as well. So if you're interested, you can take part in that as well, sir.
No, I'm more concentrating on the statistics approaches or probability approach. That's all. Nothing else. Okay. Go ahead. No,
Absolutely. Absolutely. Thank you so much. So moving on to our next part, we're just going to discuss on how to select an item, because we have 2 indices as we talked about it. We have difficulty as well as the discrimination. So how do we do the selection based on both of these indices? So obviously, when we look at discrimination index, a discrimination index can be positive or negative. Positive discrimination index is where those who are low on this particular trait are scoring low, and those who are high on the particular trait are scoring high. But if it's negative, it means that those who are low on the trait are scoring high, and those who are high on the trait are scoring low. So this is not something that we will normally be okay with. So we're going to only choose those items that are positively discriminative. So we're going to see only those items that score low for those who are low on the item trait, and for high scorers, those who are high on this particular trait. That's all we want to see. So we're going to choose only positive discrimination index. Zero discrimination index talks about the fact that your line is a straight line or there's a plateau. So this is not going to talk about any discrimination between those who are high scorers and low scorers. Both of them are at the same point. So therefore, you are going to reject zero discrimination as you're only going to choose things that have positive discrimination based on our interpretation as well. And high and very low difficulty values are obviously rejected. We already talked about this, because if for high difficulty value, it implies that not a lot of your samples are able to answer, majority of your samples are unable to answer. So it doesn't make sense to include this item, because if only 1 or 2 people in your entire sample of 20 are able to answer, it doesn't make sense to include this particular item. And if an item has really low difficulty, then almost all of them are able to answer, which means it's just 0.1 extra for everyone else in their total. So it does not make sense to include that particular item as well. If everyone is going to get just 1 point extra, then it doesn't make sense to include that. So therefore, both really high difficulty and really low difficulty items are rejected. So what we need to really concentrate on is this fourth point, where both DI and DV are complementary. Apologies for the error in the spelling, but they're complementary to each other. Just because one item is discriminative does not mean that it is high on, it is not a difficult value, or they are not going to contradict each other in any manner. Both of them work together. So if an item is both difficult and discriminative, those are the items that we will choose. So if there is a moderate level of difficulty and there is pretty good items and not really very good items also, that's okay. We will choose moderate difficulty and better items which can be working in our tool. So that's something we can choose. We do not need to always go with better, moderate difficulty and really good items. That may not always be the case for us. So we can work with how the combination of these two will work, right? So that's something we can consider based on our variables. And both should be considered when selecting good items. This is what I said. So it should not be completely only based on the difficulty value, nor should it be based on the completely on the discriminative value. We can have very good items that are highly discriminating, but do not have much of a difficulty value as well. Or we can have very good items that have really high difficulty value. In which case, we will have to discard those items that have really good discriminative power, but are really difficult as well. Because it will not make sense for us to include that into our tool, because most of our population are not going to be able to answer the most difficult item. So therefore, we need to consider both of these indices when we are including an item into our test. And the last point is again a repetition as we discussed earlier. If an item has 0 or negative discrimination, it is to be rejected irrespective of the difficulty value. Even if it's moderate difficult or even if it's acceptable level of difficulty, we are to reject it because this will not be something that we will typically look for in all items at all. I hope that makes sense.
Basic question. Why we really do this? Trying to understand all these things and everything. When already something has been, let's say GAD itself, the 7-pointers question, it's been proven that this is how it works and everything, all this stuff. So is it for the new kind of any evaluations is what?
Exactly.
Nothing else. So
yes.
Since you are my thesis in charge, so if I am launching that work from home something questionnaire or something like that to validate whether the items are working sense, I need to use this.
Exactly.
Okay.
So these are for only those things that you're newly constructing from the scratch, so that you're now getting an idea of which items to be included and which items to be discarded. For those tools that are already established, they are already having all of these item analysis done to them, reliability, validity, factor analysis. All of these things have already been done for those tools. So they already have those values. The reason why I gave GAD is because it's a very short scale things that you're already familiar with, so that can easily work with our understanding on it. But apart from that, these item analysis is an entire thing that's only applied to newly constructed tools that you're still working on to understand where your items are, how to choose the right item, how to discard a wrong item, how to improve your items to make the values better, and so on.
So in that case, the value 0 really has to be interpreted right way, right? Because if I really given a parameter that it doesn't have any impact as a 0, so that gives me that yes, that doesn't have, but wherein people didn't understand that question and gave a 0 majority, that's kind of a contradicting, right? So what we wanted to achieve, just because somebody gave a 0, we are trying to consider it as a discriminated or that value is not in a range, something like that.
It depends on how we are looking at it as well, sir. Because based on GAD, this was our interpretation. Those who scored themselves as 0 only will score themselves if they are not able to, associate themselves with any anxiety behavior. That is our assumption. But of course, we need to control for people who are also going to say, I'm not sure, therefore I'm going to control for 0. So this is also something we'll have to work with later on as we're going into the entire statistical part. This is just a basic framework of what we need to know. In this, we have a lot more things to control for, apart from just guessing. We have to control for extraneous variables. We have to control for their samples, emotional state, mood, the situation that they are being given these items in, things like that. All of those need to be controlled.
Agreed. So because majority of these are Likert scale based model only they will be leveraging, right? So that's what I'm saying. To really get this line item analysis, so any new thing should be even like in a typical way, like NA, not applicable kind of
Yes.
response should be there. That will only give you the
Yes.
right interpretation.
Absolutely. Absolutely.
Okay.
Any other doubts from anybody else? Can I stop sharing the screen?
Yeah, sure.
Awesome, because I cannot see you all when screen sharing. Dharani, does that make sense to you? No doubts. Okay, awesome. Thank you so much.
So where are we heading now? So we had a session and Monday I know I missed it. So where are we heading now?
So we have completed paper 1 in theory, which is about the various kinds of tests, various things about applied psychometry and psychometry. We have started our unit paper 2, which talks about the entirety of various scales, various types of scales. I think that was covered by Ishani ma'am. And we've also come into item analysis. So once we have an idea of item analysis, we now get into reliability, and then we'll talk about validity, because these are the major areas where we have to look into for a tool. And once we're done with reliability and validity, our final paper talks about norm, because this is what we need to establish for an upcoming tool.
Okay, got it.
So this is our entire trajectory. We're just going through the entire process of understanding how to properly construct a tool with the basics of your understanding. Because if you are really going to construct a tool, this is going to give you a foundation on which, of course, you can consult experts. You can go ahead and read up on your own and become a better construction with regard to the tools and things like that.
Okay. Maybe I'll check that video because the Ishani session is talks about the variables, how the different types of variables that she spoke about. We had a little practical activity also there doing that. So I'm trying to connect the dots where it is heading towards. Let me finish this video.
Yes.
If you have any questions, I'll post it in the group.
Of course.
Yeah,
you're welcome to ask
sir.
questions. Awesome. Ma'am, anything else to add, ma'am?
No, I think doubts, yes, Prasanna sir, and how you are doing, Prasanna sir, that's what I wanted to ask you. All fine?
Yeah, getting better. Still, COVID is a
Great.
COVID, right? It takes time.
Great.
Yes.
And yes, once the class is over, sir is sharing all these videos in YouTube. So whosoever is missing the classes, please, we request you to go through those videos, and anything, any doubts, anything in Google Classroom also you can share. So we will be answering that. And Srishti, I am a little bit worried with her because she is missing the classes.
I think we can call and have a word with her maybe, ma'am. Let's see what we can do about it. So apart from that, the assignment that I'll be assigning to you with regard to this particular paper here in item analysis is the same thing that we discussed. So you'll be applying the same formula, you'll be calculating the values, and you'll be giving me the interpretation. So I'll post the PPT as well as the assignment in Google Classroom so that you can complete it by probably even next Friday, if that's possible.
Give me some time. 31st May is the last date for assignment submission. So
Yeah. Absolutely.
I'll be coming
sure.
to Shashun to submit the documents on 31st only.
No,
Okay.
that's why we are giving it well ahead, so that you will be having enough time to
You have the entire week next week to
collect
complete.
the responses. Yeah, that's
But
what.
still, Anindita, I'm always a last day student, so I take it in the Thursday night only. Don't worry.
Yeah, absolutely.
Okay,
I
sir.
understand what
We
you're
know
talking
yeah, we can understand. It's okay.
Thank you, sir. I think with this we'll wind up, ma'am.
Thank you. Cheers.
Wind up for today. Yeah.
Yes. Good night. Thank you
Good
so
night.
much.
Good night, all.